Good morning, good afternoon. Welcome to the Avi Networks webinar. Today we are speaking with Nuage Networks on private cloud case studies, how Nuage and Avi have come together to build joint solutions with a financial enterprise and a cloud service provider to build private cloud using SDN technology. My name is Ashish Shah. I'm in Product Marketing and Technology Alliances at Avi Networks. With me here is Amir Sharif from Nuage.
Thank you for having me, Ashish. I'm Amir Sharif. I work on business development opportunities at Nuage Networks and develop our partner ecosystem.
Thank you, Amir, for joining us. We'll get started. This webinar will be recorded, and a recording will be available in a couple of days. Feel free to ask us questions. There's a question box on the GoToWebinar panel, and we'll try to answer them at the end. Here is a rough agenda of the webinar today. We'll start with the first few minutes of discussing what's happening in the deployment of private clouds. What are some of the challenges that our enterprises and CSPs are running into? Then we'll dive into Nuage and Avi solutions, both individual products and then what the joint solution looks like. We'll then spend majority of the time on the case studies that we referred to earlier, including a live demo. And then we'll wrap it up with next steps and Q&A from the audience. All right, so let's get started. We have seen an emergence of an interest in private cloud deployments. And there are multiple reasons behind it. Customers who want elasticity and flexibility without compromising the security and compliance requirements, especially in the financial industry. The other reason that's driving the private cloud deployment is with the SaaS providers and e-commerce vendors and any other company or enterprise which uses IT as a competitive advantage, from whom customizing the cloud environment to what suits their needs is key. And finally, maintaining the control over the whole environment and reducing the cost is another key driving factor for open cloud, for private cloud deployments. The other development we're seeing is emergence of OpenStack. Within a few short years, OpenStack's become the de facto choice for OpenStack, open source cloud orchestration. It's an active community with folks from end users as well as vendors contributing to a feature-rich environment. However, there are still some challenges with OpenStack-based cloud deployments, especially when you're building an enterprise-grade cloud. We'll see some of those in the next slide. Before we do that, though, Amir, from your point of view, what are some of the things you're seeing in SDN or software-defined networking, and how does it play a role in private cloud deployment?
Well, Mark Andreessen famously said that software is eating the world, and SDN is an example of software eating into the traditional hardware environment. The first point I want to focus on is innovation. Because of Moore's law and the turns on the x86 chip architecture, and because software is a lot more flexible than the traditional ASICs that you see inside hardware equipment inside a network, innovation can happen at a much faster pace inside the infrastructure, inside the data center networking infrastructure than was previously possible. So that's one of the key values that SDN unlocks today. Second is the notion of flexibility, that there is a economic drive that companies have for wanting to lock you into a certain architecture, whether it's hardware, whether it's a hypervisor. SDN allows companies to have flexibility of choice by going with a number of L3 equipment vendors, so you're not pegged to a particular vendor, and that helps to increase competition and reduce cost. And if the SDN solution is built correctly, you also have the ability to interface with many different types of hypervisors, whether it's ESX or Zen or KVM or Hyper-V. And because it's program-driven, you can automate it. With the right set of APIs, we do use RESTful set of APIs, you can plug in the SDN layer into a cloud management system like OpenStack or any other cloud management system that uses RESTful APIs and automate operations and free up resources because machines are doing most of the work. And because machines are doing the work, you can operate at a scale that was previously not seen before in a software-driven world. As a case in point, in one of our deployments, we are operating over tens of thousands of servers and a very large data center overseas. So we do see that scale at play today.
Thanks, Amir. And I totally can relate that to those points, because as we've built our L4 to L7 solution with application delivery and analytics on the similar SDN principles, we see the same benefits for our customers. So before we go into details of the solution itself, let's talk about the top 5 private cloud challenges that we see in our customer environment. We talked about the emergence of private cloud, but there are still some challenges as the enterprises move their workloads from their on-prem dedicated infrastructure to a cloud environment. First of all, they want to make sure that in the cloud environment where you're sharing resource with other tenants or other applications, even if it's a private cloud, your applications get the right amount of availability, security, and performance SLAs. And you're able to monitor those in real time and get real-time analytics, which provide you actionable insights to make changes to your application environment so that those SLAs are continuously maintained. The other challenge we see is the elastic scalability, right? Cloud is supposed to give you that on-demand experience. You need to make sure that the private cloud that you deploy comes with auto-scaling capabilities, whether you're scaling out or scaling in, scaling up or scaling down. A key requirement that's related to that is multi-tenancy. How do you ensure that whether you have multiple departments or just multiple application groups, or in the case of a CSPs, multiple end customers, how do you make sure that they don't step on each other? They have the SLAs guaranteed for each of those tenants and maintain both control plane and data plane isolation. And finally, to the points above, is operational simplicity. How do you do all of these at scale in a self-service, automated fashion, in an intelligent fashion, so that your overall complexity doesn't go up with the scale, and as a result, your cost doesn't go up? I mean, from your point of view, as you talk to customers at Nuage, how do you see these challenges playing out in their environments?
The 5 points that you've highlighted are exactly the 5 points that we're seeing in the SDN space. They are basically inherent to the cloud, and they reflect themselves at various layers of the cloud. So the system that we've built, Nuage VSP, or Virtualized Services Platform, addresses those 5 points in principle. So if you could go to the next slide. So what we are seeing right now on the right-hand slide is the stack in which we're operating. I'll start from the bottom of the stack and work my way up. What we see at the lowest level is a virtual routing and switching, or VRS. That's a distributed switch router that operates at L2 through L4. It's integrated into the hypervisor, whether it's ESX, Hyper-V, Xen, or KVM. And it then programs, it is programmed by the controller, which is the upper layer, to provide connectivity between VMs. The controller, which is the virtualized services controller, is what we have derived from the Alcatel-Lucent 7X50 routers. Now, the 7X50 routers are in the 40 of the top 40 service providers around the world. As you know, the internet scales well, and the Alcatel-Lucent routers actually run the internet. So by virtualizing the controller and having brought it to the enterprise, we're bringing a highly scalable, feature-rich controller into the SDN domain. And that's unique in the industry today. By having a code base that's very mature, very stable, and very feature-rich, the controller allows the enterprise to scale and have the level of automation that we discussed previously. And then finally, we go to the virtualized services directory, where we provide a simple way to create policies and abstract away complexity. And this is also where we have a Hadoop cluster. We would gather lots of information about the network and allow analytics to happen. So going back to your points before, you talked about enterprise-grade analytics, elasticity, scale, multi-tenancy, and operational simplicity. Those are what we have built into the VSP platform. Now, if we could advance a little bit further, looking at the top level, which is the virtualized services directory, that's where the APIs interact with various cloud management platforms. We talked about the flexibility of platform and freedom of choice. We operate with OpenStack, with VMware, with CloudStack. And the virtual services directory then talks to the controller. The controller is able to federate itself using BGP protocol, and that allows a certain level of redundancy. That's the enterprise level of enterprise grade level that companies anticipate, and this is why financial companies are keen on this particular solution. And using the same BGP protocol, we can peer with a physical infrastructure and go out to the edge router. So we're not isolated into this SDN bubble. In fact, the SDN interacts with the physical layer quite nicely. And again, that's part of the control automation and enterprise grade level of controls that we have. And finally, we go to the IP fabric, where our switches are integrated inside the hypervisor. We also can talk to a hardware or physical gateway, where we then peer with bare metal servers on the same fabric. So this provides a pretty good overview of what we're doing with our solution, and we have partnered with you in various opportunities. So I'm eager to hear about your cloud application delivery platform.
Thanks, Amir. Thanks for the overview of Nuage's VSP. I'll spend a couple of minutes now on explaining what Avi does and then how it integrates with Nuage's VSP. What Avi Networks has built, the Cloud Application Delivery Platform, is the next generation ADC, or application delivery solution, with integrated inline visibility and analytics. The way it works is that whether your users are mobile or desktop, and your application is running on on-prem data centers or in a cloud, the Avi Network solution sits in between, providing full-featured load balancing, application security, and application acceleration features. These are your traditional ADC features, as well as end-to-end visibility and analytics from users to the applications. The goal is to guarantee the end-user experience and optimize the resources serving the applications. It's a full-featured ADC, as I said before, and it provides the visibility and analytics without any monitoring fabric, span ports, or agents in your applications. We'll see that in the live demo. Similar to what Nuage VSP, we integrate with VMware vCenter. We work in a vCloud Air environment. We work with OpenStack and other cloud management platforms. We'll also have an AWS support coming out. Let's talk a little bit about how the Avi solution has been built. It's built on the similar SDN architecture. The brain of the system is the Avi controller. The whole solution is, by the way, a completely software solution. It doesn't require any custom hardware. It runs on your standard x86 servers as VMs or on a bare metal in a container environment. So as I said before, Avi controller is the brain of the system. It runs in a clustered fashion, 135 VMs for high availability, and it provides centralized policy-based control, management, and point of integration. So this is the piece of the solution that integrates with OpenStack, with Nuage VSP, as well as the other ecosystem components. It also has a built-in big data analytics engine. And as the metrics and the logs come in from the distributed data plane, it churns out analytics and actionable insights. The other key component of the solution is the distributed data plane called Avi Service Engines. Think of these as micro load balancers, with providing load balancing, acceleration, and security services, as well as they have integrated data collectors that are collecting hundreds of metrics every second and pushing them up to the Avi controller. Unlike other virtual solutions, you have a single point of management and control regardless of how many micro load balancing instances you have. Avi controller automatically manages the life cycles of these service engines, spinning them up, spinning them down, scaling out, scaling in, providing HA, and so on. And on top of Avi controller, with the RESTful API, we have built the Avi UI dashboard. Now, the REST API is a first-class citizen in our solution. That's the only way to talk to our product. Everything, including CLI, is built on top of that. So Avi UI is the analytics and application delivery dashboard, providing real-time visualization, management, and reporting capabilities. All right, so now that we have talked about Avi's load balancing and analytics solution, and Nuage's network virtualization platform. Let's jump into the joint solution, how these solutions have come together. I'll show this in two different ways. I'll start with the logical deployment model. So in an OpenStack-based cloud environment, that's a use case I'm going to use here. OpenStack, as a compute orchestration platform, brings up your servers with virtual machines and an application that's running on that. The Nuage's VSP is then providing the connectivity between these application components with the VRS running on every hypervisor, and then the centralized controller in the services directory providing the policy and control in a centralized fashion. Of course, running as an HA mode. The Avi solution then comes in with the Avi controller integrating with both OpenStack and Nuage's VSD, spins up Avi service engines in the proximity of the applications. So it knows which hypervisors, which servers the applications are running that need these application delivery and analytic services, spins up the VMs on demand, the service engine VMs that is, and providing full app and tenant isolation. It also takes care of scaling out and scaling it, as I mentioned before, to make sure as the application performance demands go up, as the user demand goes up, it automatically scales out the service engines and the backend application infrastructure, and then similarly it can scale back in. Let me jump into a network connectivity piece of the solution. So in this diagram, I'm showing you how the joint solution is deployed at the network level. What you see here is that the Nuage's VSP managing the overall network connectivity and OpenStack managing the overall orchestration of the cloud. The Avi controller runs inside OpenStack. It's not unlike other appliances which run outside of OpenStack. Avi controller actually runs inside OpenStack as another VM or a set of VMs. There are three distinct networks on this deployment. You have your backend server-side network where your applications are connected. You have your front-end client network, which could be internal or external to this deployment. And then you have your service engine and controller management network in which your Avi controller is communicating with service engines. Your service engines are present in all three networks, right? Because as the traffic comes in from the client side, load balancing the traffic to the backend server, the Avi service engines both on the client network, the backend network, as well as on the management network. And as I said before, the traffic comes in, it automatically load balances them. In this picture, I'm showing you two service engines. They can run in HA mode, so it can scale out. The two service engines can run in active-active fashion, increase the performance to double the capacity. They can also run in active standby mode if that's the HA model that you have. All right. So now, now that we have talked about this, let me hand it over to Amir and let's discuss what are some of the deployments that we have seen with our customers. Amir, do you want to talk about how we've worked together in a financial services use case?
Of course. This particular financial institution that has been around for decades, multiples of decades, basically is a well-established company, and they were experiencing a set of issues. The first thing that they had done was that they are a virtualized environment, so they were very flexible on the compute side. But as the number of VMs were exploding inside the data center, they were starting to exercise the limits of the legacy network. So VMs were moving around, the policy wasn't necessarily moving around with them, and as the data center was scaling out, the problem was becoming more apparent. The first attempt to solve the problem was to go with a VLAN type of solution. And as the number of VLANs crept into the thousands, it became a massive headache for them, massive management headache, and lots of manual configuration was needed. Aside from that, they had a number of cost issues, which is because of their scale, they had an annual refresh cycle on 1/4 of their networking equipment, and it was effectively a race to keep up with hardware features, and because of the proprietary nature of the equipment in their data center, the costs were rather high. And on top of it, there was a lot of support costs and operational costs that were coming in. What they were after was a more flexible infrastructure that actually reduced costs. So they want to take the existing solution, which was low flexibility, high cost, and make it into a high flexibility, low cost situation. So the bar was to lower operational costs by introducing SDN and AVI networks into the solution. So Ashish, I understand that you actually have a demo.
That's right, Amir. So we have a demo environment that is set up to mimic this particular case. It's a simple demo, and then let me quickly go over what that looks like. We have a financial enterprise with two departments or tenants, a dev test environment and a production environment, each running a set of applications. And the goal is to create on-demand an application delivery and analytics service for one of the dev test application. Okay, so at this point, let me switch over to my browsers, and I'm going to get help from Siva, who's our lead engineer responsible for the AVI and Nuage integration, as well as an OpenStack architect at AVI Networks. So bear with me as I switch my windows and go into both the OpenStack UI and Nuage UI to get started. All right, so Siva, over to you. So first thing we're going to do is we're going to log into the Nuage's UI and show you what the environment looks like from a Nuage dashboard. All right, let the demo gods be on our side as we try to log into the live demo system. There you go. Excellent. So we'll click on the enterprise that we talked about. Has one domain. This is the Nuage UI. And as you can see here, there are two zones on the system. The top one is the zone that we'll be working on. This is the dev test zone. It has multiple applications. What you see here is that there are multiple networks, similar to the picture that I'd shown you before. There is the AVI management network. There is the backend server network. There's a front-end client network. And in this case, we also have an external connectivity network going through Nuage's VSG.
So this is the Nuage UI that we're getting a network view, correct?
That's right, Amir. We're looking at the Nuage view of the network. Let's look at the same environment from the OpenStack point of view. So here I'm logged into the OpenStack Horizon dashboard showing the network topology. What you see here is, again, those three networks that are exposed to this particular tenant. On the left-hand side is your client network. On the right-hand side is your backend servers that we want to load balance. And then in between, on the AVI management network, is your AVI controller that's running, ready to spin up service engines when you create a web. All right, so now what we're going to do is we can either use Horizon UI through LBAS plugin to create a load balancer, or we can use an AVI UI to create the same load balancer. For this demonstration, I'm going to use the AVI UI to create the load balancing instance so that you can get familiarity with how it looks like.
And to be clear, it doesn't matter where I do the action because I'm exercising the same APIs.
Exactly right. Whether you go from LBAS API on Horizon or you go from AVI UI, they're all talking the same REST APIs into the AVI controller. That's why it doesn't matter. All right, so now we have changed our dashboard to the demo tenant. We're in the tenant context, and we're creating a new virtual service. This is our UI in which you can take less than 30 seconds to create a new web. We give it a name, we give it an IP address. If you have a DNS entry, you can just use that. Instead of configuring the network manually, or rather configuring the backend pool servers manually, I can actually select the backend network and automatically pick up the servers from there. So in this case, we have discovered that there are two pool servers, two backend servers in my environment. We add them, save, and I'm done. So just take a pause here and think about it. What used to take you hours, days, procuring new equipment to create your new load balancer? It took you 30 seconds. This is real cloud-like functionality. This is what you need in terms of on-demand creation of your application delivery instance.
So what ESX did for compute and Nuage Networks has done for SDN, you've now done for load balancers.
We have done for load balancing and analytics as a service, yes, absolutely.
It's a new cloud world. I love it.
That's right. So at this point, the load balancing instance is coming up. It's spinning up new service engines. As you can see here from the Horizon dashboard, the new service engine is being set up. It is in multiple legs. It's in 3 legs, as a matter of fact. It's in the front end network for the clients. It's in the AVI management network for talking to the AVI controller, and it's a backend pool network for talking to the servers. So again, we did it through the AVI UI, but it's reflected in the OpenStack dashboard. Let's go to the Nuage dashboard and see now what's going on. So back to the AVI management. Let's start with the front end network. As you can see here, this is your AVI SE, and the other VM is your client. Let's go to the backend network, where instead of having 2 backend servers, you also have a third VM, which is your AVI service engine. And then if you go to the AVI management network, again, you will see not just the controller VM, but also the AVI service engine VM. Excellent. So now let's go back to the AVI Horizon, AVI UI, and let's see if the SEs come up. It's still coming up as we speak, and you can actually, as a matter of see here, okay, looks like it's up. And the health score is 0 because it's not really seen any traffic. But at this point, your load balancing and analytics instance is ready. Well, now what we're going to go ahead and do is we're going to send some traffic. So let me change my view to a real-time view. And as you can see here, as Siva on the other laptop started sending traffic, I'm actually seeing that right here. Let me spend a few seconds on this dashboard because it's very important. What you see here is what we call an end-to-end timing dashboard. Now, this is something unique to only what AVI gives us today in the industry. What the end-to-end timing dashboard tells you is the end-to-end latency from your client to the data center where the load balancing instance is running. In this case, it's a local client. The server RTT, the application response time, and the data transfer time. We're able to give you that without any agents or monitoring fabric at all. It's by sitting in as a full proxy, an L4 and L7 proxy, we're able to give you the client RTT, the server RTT, the application response time, and the data transfer time at any second that you see here. We also have a health score that measures the health of the application and so on, and we have other videos and demos on our website that go into details of these. But what I will do at this point is let me switch to another system where I can give you some meaningful latency numbers to give you a real life example. So I'm going to log into another system that I have. Bear with me. Okay, so this is another system that I have where I have a bunch of applications. Let me go to the SharePoint application. So in this case, what you see here is, again, you have some more rich data because I have some traffic running. What you see here is that over the last 6 hours, on an average, my clients have taken about 36 milliseconds to come from wherever they are over the WAN or local network to the AVI load balancer, taken 6 milliseconds of server RTT between the AVI load balancer and the backend pool servers. The applications have taken, on an average, 441 milliseconds to process the response. This is the time that application is actually taking after it receives the request on that server and before it starts sending out the response. And then finally, the data takes about 66 milliseconds with a total latency from the client side of about half a second or just above half a second. As I said before, this is done without any agents anywhere in the system. This is unique to what we do. Not only that, while I'm here, let me also show you another unique feature, what we call client logs. So what we do is, in addition to being a proxy, we have these service engines which are collecting hundreds of metrics every second. These are full HTTP transaction logs. And we present this in a Google-like search dashboard right here. So in this case, let me first open one of them and see what's going on. So let me see one that has some meaningful data. In this case, this particular HTTP transaction came from South Africa, somebody running an iOS and an iPad environment on mobile Safari browser. It took 31 milliseconds to hit the RV load balancer. The server RTT was just 2 milliseconds, so that's good. The application in this took over 6 seconds to respond. And finally, there was not much data because it was just getting some just a basic homepage script, so it was minimal. But in this case, imagine yourself where you're a network admin and you're trying to figure out your users are complaining, my application is slow, what's going on, network must be the problem. Well, with such a dashboard, you can actually say that network is not a problem. For example, in this case, the application is taking over 6 seconds. There are some other cool capabilities on this search bar. For example, if I were to click on just 404s here, the query with response code equal to 404 gets populated, and then you see only 404 logs. And then you can say, okay, there are over 6,000 404s. You can figure out which URIs are missing. So if I click on the URI, say out of these 7,000 logs, all of them don't have the schedule.docx. So you have a missing file on my backend server. I can also do things like, tell me which of my clients are coming on iPhone. I can just search iPhone, and boom, it searches all the logs which have come from an iPhone. Let me open one of them and you'll see what's going on. So in this case, it's somebody coming from iOS on iPhone and from Canada. You'll find a lot more of these information on our website, by the way, but I did want to show you the power of inline analytics in an OpenStack environment, going back to my earlier points of how you can not only guarantee the SLAs, but also see what's going on. You can monitor the application, you can do real-time analytics without adding hardware appliances, without creating span ports or monitoring fabrics. Excellent. Okay, so that was, I was showing you some of my analytics capabilities. Let me go back and go back to our presentation and we'll continue where we stopped. So, Amir, we showed a live demo of how easy it was to create a new application delivery instance and a monitoring service in a dev test environment with full integration. Do you want to spend some time on how we actually solve that problem at the customer?
Sure. So the customer being the major bank that we have focused on to date. So first of all, what I saw was very impressive. Congratulations to the Avi team. It's a very nice UI. And it's no wonder that large institutions, enterprise-grade institutions, want to see this type of innovation inside their network. So what Ashish showed was creation of an environment, and that particular environment, whether, let's say you build it for a particular application with a certain topology in a test dev environment, that whole environment can get promoted into production with a click of a button. And the only thing that has to differ at that point is perhaps the policies, the controls that come with it. So what Nuage Networks enables the bank to do is take an existing test dev environment, put a more robust security policy on top of it, administer it via VSP, Nuage VSP, and the workloads automatically get it. And let's say that the customer goes on and the application needs change. Mm-hmm. The load balancers need to scale out.
Sure.
Or let's say that there's a new regulatory change where policy changes are required. Mm-hmm. What our combined solutions allow the customer to do is to go to a single management pane, mm-hmm. do one change, and the entire network then gets the benefits of the new policy or the new load balancer rules. So the policy aspect of our combined solutions enables a lot of automation and centralized control, and actually reduces the rate of errors. And that was critical for a bank, especially for a bank after the 2008 meltdown, where they want to make sure there are as few errors, whether they're policy related or through injection of, let's say, bad code, that they want to isolate very quickly. The policy-based approach is key and important, paramount to them. We also talked about multi-tenancy. In this case, really the tenants are inside the bank. It's a test dev environment. It could be the HR department. It could be the operational side of the show. But ultimately, what you want to do is isolate traffic and not have one environment affect the operations of another. So if you're running something in HR, that's highly proprietary information for employees of the bank, and somebody in test dev that's running and doing experiments should not be able to see those information, even though everything's running on the same physical network. So multi-tenancy is a key part of our combined solution and a key part of SDN. We also talked about openness. So earlier I talked about the need not to lock the vendor into any proprietary solution, and giving them the flexibility so they can benefit from the innovations that are happening in the market. So no hypervisor lock-in, no equipment lock-in, whether it's servers or switches. And our philosophy is that the core of the network should be robust and should have as much capacity as you want. Basically, treat the core as an infinite resource. And because we're running on standard L3 network, if the bandwidth is getting limited inside the data center, what we allow the customer to do is go and buy the most cost-effective solution and just add ports. Yep. Just add speeds and feeds, and the customer can then scale out. And that's where the elastic scalability and performance aspect of it comes in. You don't have to wait for more expensive equipment that programs end-to-end routes between devices. Basically, make sure that your pool is low cost, it's infinite, and let the hypervisors and let the intelligence within the SDN layer and obvious controller take over and give the elasticity that you need. And effectively, this is what we deliver to this particular financial institution.
No, that makes total sense, right? Because all of these points resonate with the AVI solution as well. That's why the joint solution is so powerful. Again, our solution runs on commodity x86 servers, so it's practically an infinite pool in terms of elastic scalability. We work with multiple hypervisor environment, so openness from that point of view. It's fully multi-tenant inherently, both at the controller level and at the data plane level. And it's a full policy-driven architecture. So that synergetic architecture between Nuage and AVI is what's driving a powerful joint solution. Excellent, Amir. We had another customer, in this case, a cloud service provider. Why don't you share that case study as well, Amir?
Sure. So basically, think of what the cloud service provider does. They cater to not an individual company, but to many companies. So whether you're a bank or you're let's say a payroll processing company or a CRM of some sort, that you want to leverage the infrastructure of a cloud service provider so you can either run exclusively on that infrastructure or have the option of the private cloud internally and a public cloud as a bursting capability or for particular workloads. So this particular service provider offers enterprise-grade solutions for companies that want to run exclusively on it or want to run part of the operations. But the requirements are, because they're enterprise customers that they're catering to, is the enterprise itself has to have control over the infrastructure as if it were their own.
Right.
And it has to be reliable, it has to be secure. Because it's hosted, it doesn't mean it can be any lower quality than the investment that they've made inside their own data center. And also, that the cost benefits have to come from it. So elasticity is a key part of it. Let me consume as much as I need, and once I'm done with my need, let me shrink back and save money that way. So from this cloud service provider's perspective, having very low cost operations and ability to expand and shrink resources with the advantage of low cost operations built in is key. So let's go to the next slide and see what we've done together. So what we delivered was a multiple hypervisor stack. Now again, we talked about the ability to talk to KVM, Xen, Hyper-V, or ESX. Well, this particular cloud service provider offers 3 of the 4 hypervisors as a service. And they offer tenant isolation. So tenant A, tenant B, tenant C, let's say Coke, Pepsi, Dr. Pepper, can be coexistent on the same infrastructure, but their operations are invisible to each other. Now let's focus on tenant A. Again, you can replicate the same operations that we saw in a large bank, which is Department 1, Department 2, Department 3, whether it's development, HR, finance. They can be parts of tenant A, and their traffic is in turn is invisible to each other. They still have isolation. So there are multiple levels of isolation that driven together. And what you have enabled each of these tenants to do is to deploy load balancer as a service on demand to scale out operations.
That's right. That's right.
So the benefit for the customers is that whether they're a startup or the enterprise, they're getting the same level of service from this cloud service provider. And if you're an upstart and you're coming in, you really have no IT disadvantage.
Makes sense. That's especially important for companies who use IT as a competitive differentiator. So makes sense.
One of the things that we sort of have touched on but haven't really talked about in depth is one of the aspects of how we save the customer money together is by allowing them to preserve the value of their existing CapEx.
That's right.
We don't require any hardware upgrades to get a new feature. It's basically a software refresh. So a server that used to have a 3-year lifespan can now have a 6-year lifespan. A switch that used to have a 4-year lifespan can have an 8-year lifespan. And that's a tremendous amount of savings for companies like this cloud service provider or the previous bank that we talked about.
That makes a lot of sense, right? Because as they can add new servers or add new commodity hardware and just keep scaling out where the features are coming from the software layer, both L2, L3 level, as well as the L4 to L7 services. Excellent. Thank you, Amir. So that brings us to the end of the presentation. What we saw in this webinar was that how the joint Nuage AVI solution helps the customers, both enterprise and CSPs, accelerate cloud adoption by increasing infrastructure flexibility and reducing OpEx and CapEx. Guarantee SLAs for business critical applications, right? You have peace of mind that as I deploy my workloads in cloud environments, they will meet the requirements that I need. Reduced risk with on-demand scaling. We talked about how the solution scales elastically, and you'll see demos on our website as well as Nuage's website, and as well as a usage-based cost model. So again, there is no risk in terms of over-investing in your infrastructure. And finally, for the cloud providers, it's a way to differentiate from their competitors, offer rich services to their customers and grow their top line. So at this point, we're ready to take questions. In terms of the next steps, our contacts are listed below. We'll also be demonstrating a joint solution at the OpenStack Vancouver Summit, which is about in a month and a half. And on Avi Network side, we have a free trial that you can get started on avinetworks.com.
Yeah, for whoever that's on the call, if you're going to the OpenStack Vancouver Summit, I do encourage you to go to the Avi booth, our booth. You'll see a reference platform that incorporates our and other solutions, showing the openness of the OpenStack environment and how we work together to deliver enterprise-grade solutions. So please do stop by. We look forward to seeing you there.
Thanks, Amir. So yeah, we have a few questions, and I think we do have a few minutes to answer those questions. So the first question was, is the session recorded? The answer is yes. Second is, what is the benefit of using the Avi API against Horizon? That's an excellent question. The LBAS plugin API is constantly evolving. So as we go from the Juno release to the Kilo release and so on, they're adding capabilities. However, Avi has built in advanced capabilities that's not yet available in OpenStack. So if you need any advanced capabilities, if you need to see any analytics dashboard, for example, that we saw, you would come to Avi UI. If you just need basic load balancing, VIP creation, it doesn't matter which interface you use. As we saw in the demo, even though we used Avi UI, it's reflected in Horizon Dashboard. Similarly, you can use Horizon Dashboard. It's reflected in Avi UI. The difference, as I said, comes in advanced capabilities. All right. The next question is, does Avi work with other SDN controllers and an environment? The answer is we are similar to Nuage. We are an open ecosystem. Yes, we do have other partners. You can check us out on our website at avinetworks.com and browse your way through the partner link.
What, you mean you have other partners?
We are an open ecosystem, Amir. There is one more question as to, at OpenStack Summit itself, can I try this hands-on? Or even today, if I am interested in trying this hands-on, is it available? So I'll speak on the Avi's behalf, and then I'll give it to Amir. Yes, from Avi's point of view, as I said before, you go to our website, you can start your free trial. We also have an online sandbox in which you can play around in an existing environment. Amir, how would somebody get started with if they're interested in the Nuage solution?
I would suggest that you either contact me with the email address that's listed there or send an email to info@nuagenetworks.net. We'll be glad to provide a demo and hands-on experience within our labs as needed.
Excellent. Okay. Looks like there are no more questions. So thank you very much. Again, thanks, Amir, for joining AVI Networks in our webinar series. And thank you, everyone on the call for joining us. My name is Ashish, here with Amir from Nuage. We appreciate your attendance. You will see the link to the webinar recording sent to you in the next couple of days. Thank you.
Thank you.